Hello and welcome back to Higher Maths Functions and Graphs Sketching Trig Graphs. We're going to have a look at a radian question now. So we've already looked at doing a degree question. So example 2 here is essentially the same skill as example 1, except we're working in radians. So sketch y equals 5 cos x plus pi by 3 minus 4. So again, first thing to do is to think about what transformations are going to happen to the original y equals cos x graph, which looks like this. So we have y equals 5 cos, so that's going to stretch the cosine graph by a factor of 5. So the y coordinate will be 5 times as large. Then we have cos of x plus pi by 3, so that's going to move the whole curve by pi by 3 radians, which is 60 degrees if you like to work in degrees, to the left. And then minus 4 will move the whole curve down by 4. So again, if we're setting out our work in this way, it should be, well, this is a reasonably tricky question if I'm being honest, but if we've got the method in place, hopefully it'll be, I'm going to say straightforward, but that's maybe not the right phrase to use. So what's happening to all of the x coordinates? They're all moving pi by 3 to the left. What's happening to the y coordinates? They're all being stretched by a factor of 5. They're all becoming 5 times as large, so 5y, and then they're all moving down by 4, 5y minus 4. So take the key points on the cosine curve. So we've got 0, 1, we've got pi by 2, comma 0. Remember guys, it is a radian question, so don't do as I've done there. I'll try to write 90, comma 0 to start with. Then we've got pi, comma negative 1, which is normally 180, comma negative 1 if we're writing in degrees. And then 270, 0, which is 3 pi by 2, comma 0, because pi radians is 180, pi by 2 is 90, so 270 is 3 90s. So that's 3 pi by 2. And then we've got 360, comma 1 as we complete that full curve. So 2 pi radians is 360 degrees, so 2 pi, comma 1. Right, so now do the transformation to each of these key points. So 0 minus pi by 3. So we've got pi by 2 minus pi by 3, so that's 1/2 minus 1/3, which can be written as 3/6 minus 2/6, which will be 1/6. So 1/2 of pi minus 1/3 of pi will be 3 pi by 6 minus 2 pi by 6, which will be pi by 6. Then we've got a whole pi minus pi by 3. Well, a whole minus 1/3 is 2/3, so that'll be 2 pi by 3. And I've got 3/2 minus 1/3 again. Go for a common denominator, so 3/2 is 9/6, 1/3 is 2/6. 9/6 minus 2/6 is 7/6 of pi. And then 2 wholes minus 1/3 will be 5/3 of pi. And then we need to transform the y coordinates as well. So 5 1s minus 4, 5 0s minus 4, 5 negative 1s minus 4, etc. So remember, our curve will be a cosine curve, so it's still going to have the same shape. And the one thing that I've not talked about is finding the y-intercept. So an x-coordinate of 0 substituted in will give 5 cos of pi by 3 minus 4. So cos of pi by 3, cos of 60 degrees is 1/2. So that's 5 over 2 minus 4, or 5 over 2 minus 8 over 2, which would be negative 3 over 2. So mark on the y-intercept, mark on all of these key points. So remember, we're sketching, well, I've not actually said it in the question, I should have done, it's quite sloppy. We should be sketching between 0 and 2 pi, which is 0 and 360 if we're talking in degrees. So this point here, 2 pi radians later, we should be at that height again, because the graph has a period of 2 pi. Okay, so I've got the key points on. I've not marked on the x-intercepts because we've not calculated them. And we don't know how to do that yet. We'll look at that in Unit 2. But there's the curve. I've got the maximum point and the minimum point and the y-intercept, which is more than enough.